So, very good afternoon, everybody. So, very pleasant to have you all here at the 8th Masterclass session by Dr. Sumitava Mukherjee. So, let me introduce about Sumitava. Dr. Sumitava is a PhD in cognitive science from IIT Gandhinagar, graduated in the year 2014. After graduating, he worked as a postdoctoral research fellow at IIM Ahmedabad, and then he joined as assistant professor at Ahmedabad University, and then he worked as an assistant professor at IIT Roorkee, and currently he is an assistant professor of psychology at IIT Delhi. Uh, Speaking of his research interests, so he has undertaken research in preference, decision making, and social cognition for over 6 years, and he has also provided consulting for market research. He has been awarded several research grants from Department of Science and Technology, Government of India. He has also been working as a reviewer for numerous journals. Uh, and today, Dr. Sumitava will be speaking on behavioral artificial intelligence, the human psychology about algorithms. Uh, Personally, when I saw this title, Dr. Sumitava, I just remembered something. I had heard that people said Facebook knows you better than you know yourself. So I hope after this session I could relate to that fact. And Further, on behalf of IIT Gandhinagar Alumni Relations and on behalf of all the IIT community, I welcome Dr. Sumitava to present this online masterclass session. And I strongly trust and encourage you all to take the best advantage of this live masterclass. Uh, Over to Dr. Sumitava.
Okay, so before I start, there's you made a very interesting point, and there is indeed a book I was reading which has gone in depth about this issue of knowing who you are. In fact, there's a whole bunch of books that people are writing nowadays. So one interesting book I have bought, I have not read yet, is called Everybody Lies, which is essentially what you can get to know about people by examining what they do on the internet. That's where actually people don't lie. Um, because only if you are able to get a handle on the window into what people's lives are really on the internet, that's where lies are minimal. But this aspect of who knows you better, I do have a slide around it. I mean, not specifically talking about a case study, but indeed Facebook research has been very active in understanding who we are for multiple reasons, including business interests. And that's why Facebook research also funds a bunch of these kinds of things. We have still now not been fortunate to get their funding. One is under review, but there's quite a bit of interesting stuff you can tell about people, it seems, from what people do on the internet, including, of course, social media sites. So yeah, let's see why that is interesting. In fact, today I'm not going to talk so much about my own research, but rather to give you, not you, I mean, to give us um, an approach or a perspective of why we should do more research on this topic. So that's where it is tilted towards for today. So let me share my screen. I hope. All right. So yeah. So this is the title, and as you know, it's already mentioned that it's tilted more about human psychology, about algorithms. So um, what I would want to start off with is, of course, when you see what we have been doing all day nowadays in the sense of, let's say, the last decade, minimally, or maybe 2 decades, this is exactly what our life has become predominantly. I mean, if you look at how much people um, spend time, so there are these interesting time use surveys that people have done. It seems that about 60 to 70% of the time, waking time, we are involved with brands which are essentially to do with electronic markets, um, in a broad sense. So, for example, even even Google has to do with electric markets, and of course, more mobility-based brands, whether you're driving or whether you're flying. And more recently, there are some time use surveys that people did in, I think, about 18, 19. I don't know if any which came out during COVID, but even our common experiences say that a large part of our life is basically spent on, these social media websites. Now, what is interesting about these brands is that most of these brands have been heavily investing in or are, leaders in the area of AI. So, why is it the case that the largest brands of the world are also the brands that are most invested in AI? So clearly, there's something that's going on, which, um, you know, which is worthy of being studied significantly and separately, apart from looking at many other things that people have done. So, for example, there's lots of research that has happened on brain-computer interfaces, um, or for human-computer interaction. People have studied the psychology of media consumption, or social media usage, stuff like that, in diverse and disparate ways. But there is something systematic here, which is that if you look at these large problems of our world, most of these problems, there are promises from many of these very large companies. Of course, I have not put in the energy companies here. They also play a very big role. Also, the agricultural companies. So most of them, again, if you add the other logos for that too, you will find that they are also heavily invested in AI. Now, if really we have to solve these big problems, and I say these are big problems because basically the scale of these problems are big. It affects the largest number of people across the world. And that's why they are important things. Some people make the claim, even organizations like United Nations make the claim that this is why, um, this is one of the reasons why we need education, because the idea is people trained in different areas will actually be able to input their insights to solve these large problems, be it about climate or healthcare and finance, education itself. And the last part is dignity, which is to do with quality of life and care and stuff. So if there are solutions from these AI, then so far so good, there should not be a problem. But there are issues. The issue is that if you also think about what are the things that we care most or we should care most in life, they are, these are the things that I could list about, which is health and education and work, mobility and travel, finance, personal and, social costs, relationships, entertainment, uh, also about living and citizenship, which has to do with security and safety and governance, uh, becoming more and more important across the world. There are also another bucket. I have also put things like agriculture and weather, which do not, which is perhaps not which we worry about every day, but our lives are heavily, dependent on them. Then if you go to God and religion, spirituality, that also plays a very large part across millions and billions of people across the world, which many a times get intertwined with politics, ideology, and news. And then we have care and dignity. Now, can anybody in the audience take a first shot into saying, why are we even talking about it? Why are these domains that we care about important for a talk on AI? Any quick guess? Can put in the chat. I don't know. I can see it or not. Um, okay, so for the sake of time, let me proceed. These are basically the domains in which we have seen the maximum traction of products and services which are to do with AI. So, the domains that are most critical to our life are the domains in which AI or the AI algorithms are making the maximum inputs. And that's why we have to be um, very serious about this stuff. And if you think about why we should be serious about it, there are multiple reasons. The three reasons I have enlisted is ubiquity, which means that they are everywhere, complexity, which means that most of the time we don't really understand what the AI algorithms are doing because they are heavily complex, and consequences, which is why the previous slide was there, which says that they have consequences across all the areas of life that seems to be important to us. Now, if you think about ubiquity, if you look at consumption, we don't just consume products, but we also consume entertainment, which is songs and videos, and most critically, news. Now, news, we all know, has been a topic of a lot of debate and discussion, which has to do with misinformation or you know pocketed information, giving rise to intellectual bubbles, sometimes called echo chambers, where people of a certain political agenda hear the same kind of things about that political agenda, or sometimes the news feeds are intentionally and unintentionally manipulated for feeding a certain kind of political agenda and information to people. Songs and videos we have everywhere. Every single product app that you can think about has recommendations. And whenever you have recommendations, you have an AI engine at the back end. And products like, Amazon saying that these are the products that is recommended for you again, or these are products that other people buy. Again, at the heart has, AI. For finance, you have credit scoring for loans, finding out scores for which are the people who should get loans, and you have a credit scoring for that done by AI, no more by people. Price differentiation, which means to find certain pockets or certain segments in the market and then price the same thing differently based on what's the segment you're talking about. Algorithmic trading and has something called robo advisors, which manage the whole financial portfolio and do the trading on your behalf without any necessity of intervention by people. In the area of security, we have seen issues and lapses with video analysis, um, local policing, which are heavily governed by suggestions that are given by AI systems, and surveillance. Now we have AI systems suggesting, not yet deciding about penalty. Um, Even there's a lot of talk about introducing AI in our Indian judiciary system by the outgoing Supreme Court of India's judge, payroll, and also in defense systems. So they are going to affect security in a large way, or is already affecting. Education, we already have automated essay grading. GRE, for example, has already introduced automatic essay grading. Admission recommendation systems are everywhere. Some organizations use it, some don't, but there's a large market about admission recommendations. Similarly, for jobs, for selection of resumes, there are also issues about selection of resumes where job posting has been, there are reported cases of job posting being tailored towards the gender or the religion of a person, which it should not be, because everybody should be posted the same job. But there are AI algorithms which tweak certain kinds of job posts accordingly. We also have a lot of software now which suggests predictive work forces, which means that it predicts the quality of work that is possibly going to be done by an employee to check attrition or to let people go or to lay up people off. So this is affecting work in a big way. There's a whole area in management now called future of work, and there's a lot of issues and questions that people have raised about these kinds of AI systems. In mobility, I'm sure most of us have used ride sharing sometime or the other, including the setting up of prices for the ride shares. And we already have semi-automatic cars. We have fully automatic planes. And there's a lot of talk about fully automated vehicles on the roads or on the, you know, well, trains we already have. Metros predominantly are almost fully automatic. Completely driverless rails is a large project that I know some colleagues are working on. And there are already driverless steamers and driverless um, tourist cars and ships that are already existing in a couple of countries. In care, there's a growing market about robo companions, which means that robots which are able to take care of either the young or the elderly, especially in areas where you know there's not so much of people who can support the family. And in relationships, we have an extremely big market for dating and matchmaking, including marriage matchmaking. Um, and obviously, we have been using Instagram and Facebook and Snapchat and WhatsApp daily, which has and will have consistently a large effect on relationships. So the ubiquity nature of algorithms, if you or AI algorithms, if you think about it, is immense, and so is the complexity, because most of the stuff that we use, it seems that we actually don't understand how this thing will work, and that has multiple positive and negative consequences. To make the point, I will talk about a couple of cases that we have already seen around. So Alpha Zero has been more modern software for chess playing, which actually uses much less number of potential moves. So it uses about 80,000 to be able to decide the next chess move, which is much less in number compared to AlphaGo or DeepMind, which actually works out millions and millions of moves. Now, still AlphaZero, using a very less number of moves, is clever, smart enough to defeat world champions, and they have done so. In Amazon, Flipkart, Myntra, in fact, Myntra did buy off a startup which was an AI startup. Flipkart again has used and does use a lot of AI in it. That's of course so does Amazon. So these nudges about saying also buy this product or setting the prices of certain products are all essentially at the back end being done by AI systems. Amazon Alexa is a very new addition, and a lot of research is going on in voice-based integration or voice commerce in the chatbot arena and the voice commerce arena, where Amazon Alexa and Google Nest and many other voice-based recognition systems, or typically called digital voice assistants, have been seeing a large boom in the market. The voice commerce industry in India has grown phenomenally. I was working with a company to work out the exact details. It's huge now. Chai, if any of you know, was a chatbot that was built by Microsoft and which simply went awry. So it became sexist, and it started saying lots of religiously colored things on Twitter. Chai was a chatbot that was made by Microsoft, and it is a chatbot on Twitter, which went bad. Many of you might also have heard about the Tesla crash, which was a very highly polarized and highly popularized news content for a large amount of time, asking questions about ethics, about human-machine relationships, about legalities and regulations about artificial intelligence and stuff like that. And more recently, there has been the Uber accident, after which, again, lots of things changed, including Uber itself giving up on automated vehicles. Both Uber and Lyft have given up on automated vehicles project, and it has sold it off to another startup in California. So we know all of this has happened, and all of these are essentially human machine interaction or human algorithm interaction that people cared about so much. So this is this was this has been talked about in almost all major news channels. This is from BBC. What happened was this was Uber's self-driving vehicle, but as with almost all self-driving vehicles, especially when tested on actual roads, it is mandated as of now to have a human driver behind the wheels who has the power to overpower the vehicle if needed. So here too, Uber had a person back at the wheel. But what happened was Uber did end up crashing into a cyclist and she died. I think she was a lady of about 49 years or so. She died from the hit, even though there was a human behind the wheel. And there was a lot of investigations happened. Multiple agencies investigated the scenario, and eventually, what turned out to be the result of the investigation is that the person who was behind the wheel, there was an attention lapse on that person's from the person's side. So the person was basically watching streaming movies on the cell phone, and even though the charge was to overpower the vehicle if required, her attention was paid to the mobile phone, and hence she was not able to do anything when the car crashed into the cycle. And that person was charged over the fatal crash. Not the company, not the machine, not the algorithm, but the human who was behind this wheel was the person which was charged for um, unintentional homicide. Okay, so this raises a lot of questions, and especially people who are interested in ethics and philosophy of AI, or about regulations and about legalities, have taken this as an extensive case study. Those who are interested in cognition have also studied this, because again, this basically is a question about human cognition labs, typically attention labs that people have studied in the driving literature for a long time. But for us, what's interesting is to see that such a case requires us to not take this up as individual cases, but something more. Before I proceed, this is one more. This was the 2010 flash crash, which this is in the New York Stock Exchange. Again, it was heavily publicized by the media, and this is from The Guardian. Most interestingly, what is the key to this is the trading was being done by algorithms. So it's algorithmic trading, which is now actually quite common across the world in almost all large stock markets. We have a large amount of algorithmic trading. But what happened that day, which is March 6th, or sorry, March 10th, I think, in 2010, is that one single event, one single mutual fund event, selling off event, resulted in this, what is sometimes called a bad potato effect, where it led to a complete fall of the market, and people saw extremely irrational prices. So there were some stocks that had become some pennies and cents, and some stocks like Apple, for example, which was about $100,000. Both of that made no sense in the market. Now, market being a market is extremely flexible, and markets have this ability to get back to reasonable equilibrium states. So it did survive the day. I mean, but in about 40 minutes, it says here about 20 minutes, 2 billion shares worth $56 billion. That's huge, huge amount of money that changed hands because people were just buying from one somewhere and selling it somewhere. Now, this is called a flash crash because, just like a flash flood, it's a flash crash because the market just crashes within a few minutes. It gets into a slope, and it just goes down and down till somebody holds it back, and there are regulators who had to come in. And then there were laws set up, and among the laws, the regulations said that certain agencies will have the right to look at the source code of these algorithms. Now, that obviously does not go well with the private sector, because people develop algorithms and make them proprietary. You don't want the government to come and see what code you have. But at the same time, this is at the cost of billions of dollars of public safety. So eventually they reached to some kind of agreement that yes, the government can have a right to look into the algorithmic source code, but not like that randomly. It has to have multiple levels of checks and balances still that is acceptable and by the court. But it does point out again to one of the issues about not understanding how AI algorithms work. In the midst of all this, if you look at the world over, every single country by now, at least the developed and the developing uh, ones, have rolled out the AI strategies. These are government AI strategies rolled out for about 3 years now. So starting out with Canada, which has been a very early taker, uh, to everybody, including the National AI Strategy for India, which was rolled out in late 2018. Um, you see everywhere. I mean, all these flags are there right on your screen, and you see almost the world over, we have AI strategies. So on one side, we have these large cases where AI has gone wrong. On the other side, we have the AI basically, becoming a part of consumer consumption industry in big time. And third, you have governance across the world, or governments across the world, ruling out these different AI strategies. So what do we do about it? If you look at India's national AI strategy, this is a discussion paper in public domain, any of you can go and read it. It's on the Niti Aayog's website. You will see that there are key aspects that, or the key challenges that they have already highlighted, which will be important for India. And it has also highlighted certain areas where AI technologies are doing very good, for example, in computer vision, in audio processing, and where it's kind of sketchy. It also does say which are the solutions that are already somewhat close to industry benchmarking or prototyping. And accordingly, multiple hubs have been created, especially in the IITs across India, where they are doing certain focused areas. So for example, cyber physical systems in Mandi, robotics in Delhi. I am aware of another iHub. So they are called iHubs, which are all funded by DST. And most of them are leading into certain development of technologies. Say, for example, cognitive robotics or speech analytics and recommendation systems, data visualization, virtual agents. Most of this has already been existing as proof of concept or rudimentary parts which are already in the market or can be developed into market products soon, which means that we are going to see more and more penetration of AI in the domains that I mentioned, which are key to our life. If you look at the challenges that are there for AI adoption in India, according to NASSCOM, which is something you can trust, you see that, of course, there are privacy, security, ethical considerations and regulations which are unclear. Long time back, I and Professor Jason had done this project on privacy, where we found it's extremely malleable in people in our country. So how much do people understand privacy? How much do people want privacy? And how much or which kind of data do people think is private is not clear. And that's also discussed by NASSCOM. We also have very low intensity of AI research. In fact, there's an India AI portal which says that across the world, Bangalore seems to be the fifth hub for AI development, which means that although we have low intensity, we have potentially large capability of AI research. The problem is that we have inadequate availability of AI expertise, manpower, skilling opportunities, and that again has given rise to a lot of recent certificate and degree programs around AI, many of them given by IITs again, or triple ITs, and facilitated by MOOCs like Coursera. What they don't say in this slide is the part of today's talk, which is one key challenge to adoption of AI in India is how people think about AI and how AI actually behaves. So go back to I went back to Hosanagar, who is a professor at Wharton in Pennsylvania, who is a technology professor and in the business school. And this is a great quote from his book, which is Human's Guide to Machine Intelligence, that he wrote, citing many examples from India too. Says that many commenters have suggested that AI-based algorithms represent the greatest current opportunity for human progress. That may well be true. In fact, that actually is the underlying basis of almost all AI strategies across the world. But, Hosnagar says, their unpredictability represents the greatest threat as well, and it has not precisely been clear what steps should be taken by us as end users. Now, talking of steps, this is why the problem is big. First of all, algorithms are not a homogeneous set. There are algorithms in different domains. The algorithms designed differently. Even if you look at the single recommendation engine of YouTube, that has three kinds of designs progressively. Now they have the hybrid AI systems. And there's a huge diversity in data. More importantly, the complexity, I think, of individual AI systems is already high, which we already know, but can be somewhat measured. The problem is that if you have opacity and if you have uncertainty, on one side you don't know what the AI does, on the other side you don't even know, what is it reaching out for, which is always true for machine learning or a large amount of machine learning. That makes even access to code useless, because code is not what will tell you what might be the eventual outcome. More interestingly, there is something about human dynamics which has that even if an algorithm is created in a certain way, depending on the environment you put in, the results will be completely different. And the classic case study of that is Microsoft's Xiaoi's, which was a chatbot which was in China, which performed very well, and it talked to people. People developed a warm relationship, double quotes relationship with the chatbot, which used to chat like a teenage girl. The same Microsoft, when it created Tai as another chatbot and put it on the Twitter, then it became, as I was saying, it became very sexist and it became very religiously motivated. It told many things which are considered unacceptable. So the same company developing chatbots, in fact, almost the same algorithm, behaves differently in China compared to differently on Twitter. Potentially, one reason is that a lot of Chinese media is regulatory, and people think what they should say and not say in certain companies or in certain countries compared to Twitter, which is much more free speech. So we can't. This is why it's uncertain. The unknowns are variables in the model or in the data that we have not even factored in. So we have risk and we have uncertainty and we have unknowns when we are talking about AI systems. All right. So given all of these, now what should we do next? So one way to proceed is what Revan and colleagues have called machine behavior. And what their point is, we have to have a new field now, or an interdisciplinary field, which they call machine behavior, that moves beyond engineering and design and testing. So now what happens is machines are developed by engineers and machines are tested also by engineers. according to certain benchmarking, which is fine, but that has a problem. The problem is that how do machines behave in different environments and in different interactions, which result in altered or can alter societal outcomes, remain unclear. So they suggest that we create an interdisciplinary area of research which where we study machines like we have studied humans or animals. So that's why it's called machine behavior. We are predominantly studying machine or the behavior of machines using quantitative behavioral and cognitive sciences. So this is a great idea, and Revan, of course, if any of you know, had started the Moral Machines project, which is a very discussed project at MIT, and now he has moved to Max Planck in Berlin. So my suggestion, or rather our suggestion is this. This, by the way, is a developing book chapter that Deepti, my Senapati, who works with me, has put together along with another intern who worked with us. And we have been writing this chapter up for a while. In fact, she has done a lot of work in this, and that will be out, and I can share it later if any of you are interested. And we are going to make this suggestion, which is that we now need a behavioral scientific approach towards AI algorithms, which is not there as of now, which categorically infuses behavioral inputs to AI research. We have seen a lot of this happen in economics, where behavioral economics led to behavioral inputs to economics. And now we have a full area now, which is called behavioral economics, that has changed economics in a significant way. And my hope is that we have a behavioral approach to AI that also changes AI in a significant way. And we do that by building on years of research that we already know that we have some faith on about human cognition from the areas of judgment, decision making, social cognition, computational models of cognition, neuropsychology, and different kinds of human technology interfaces like human computer interaction, human with robot interaction, and brain computer interfaces. I suggest let's just have two different threads. The first thread is what is the behavioral response of people towards AI? And the second thread is what is the behavior of AI itself? And when you talk of behavior of AI systems, behavior does not happen in the, in the vacuum. People perceive that behavior. So there's a sub, thread towards that, and says that, and how do people perceive the behavior of AI systems? So two threads. One is behavioral response of people towards AI, and the second is what's the behavior of AI systems, and accordingly, how do people perceive them? So if you talk about the first thread, which is the behavioral response of people towards AI, there's a whole lot of literature around it, which we are aggregating, and it has already been aggregated in one or two other summaries or meta-analysis that people have done. And these are a couple of snapshots from there. There's one thread which says that humans trust humans more, which means that people are aversive towards algorithms. And this goes a long back, it goes to back to a long time in history, where for about 40 years now, we know this thing. When you have outcomes about stock market forecasting, people prefer humans over algorithms. More recently, humans and colleagues have shown that even for subjective recommendations like jokes, people preferred humans over algorithms, although actually they enjoyed jokes by algorithms more, recommended by algorithms more than humans. They still wanted jokes to be recommended by humans. In radiology, there's the one area where AI has done this maximum amount of benchmarking is image processing. So there is some AI researchers who say that after a while, radiology as a profession itself will be gone because almost everything will be done by AI. Possibly because AI indeed it has done significantly good work, specifically in deep learning in radiology. But very recently, Gob and colleagues showed that even for chest X-ray evaluation, people prefer human radiologists more than AI algorithms. In education, if you ask people to predict who needs more tutorials, again, people want that prediction to be coming from human experts or instructors compared to algorithms. Very recently, in a small pilot study in JDM, we tested whether for exactly the same model with the same accuracy, and also if people perceive the accuracy to be same, still whether there's a bias in willingness to use predictions from humans over algorithms, the answer is yes. For COVID prediction cases, there's a large intention, greater intention of people to use human predictions compared to algorithms for exactly the same prediction. So this is one class of literature. There's another class of literature which says that humans trust humans less, which means that they are appreciative towards algorithms. Log and colleagues have found that for predicting future outcomes, for example, certain sport matches, or for just simple, perception tasks like judging the weight of a person, people prefer algorithms over humans. For investment R&D, for R&D investment, Kading and Missinger more recently showed that people prefer algorithms. For investment trading and for fund management, it's an immense amount of work which shows that people actually prefer algorithms over humans. So you see that there's for a bunch of stuff, people prefer humans over algorithms, and for a bunch of other stuff, humans prefer algorithms over humans. What is special into these is that many of these things, algorithms actually perform better than humans as far as benchmarking is concerned. But still, people end up wanting to, you know, be more favorable towards humans compared to algorithms. If you go towards more embodied AI, which is predominantly robots, we have been measuring the acceptability of commercially available robots. These are all the robots that are documented on the IEEE website, which are already existing in the market. So there again, we see that acceptability of robots and how much you trust the robots, or how much, or what you would want the robots to do, including taking care of, your loved ones and stuff, varies immensely based on multiple properties, including perception of mind on robots, which have to do, or has correlated at least, with the physical properties of the robots, which look very differently, innate properties that we think robots might or might not have, risks involved with the tasks, and what is the domain you're talking about, for example, in healthcare versus defense versus education. Uh, there are four important points I want us to note. One is, what are tasks that humans do? So we do not actually do a lot of forecasting and prediction. We are extremely bad at predicting anything. However, machines are fantastic at predicting, especially machines working with large amount of data. So humans are good in evaluation tasks. Now, if we build AI systems which are good at evaluation, AI systems are already very good at prediction. But evaluation is something that's a good test bed. So if you have AI systems which are good at evaluating something, so for example, if an AI is able to see this and say, okay, this is a dangerous tumor versus this is not a dangerous tumor, then that's an evaluation. Or if an AI system is able to see and say, this is an orange which is going to taste sweet compared to not, then this is an evaluation. What are the types of data that humans work with? We typically work with small amounts of data, and some experts in the area of expert decision making, we know something called experiential patterns. So experts are able to understand patterns in the data and make sense of it, including on the spot decisions like those taken by surgeons or those taken by firefighters that Klein talks about, and other stuff. The characteristics of algorithms also matter. So are we benchmarking performance, which means that is the algorithm better objectively compared to a human? Or are we benchmarking process, which means the algorithm is doing or processing as if or similar to what an algorithm does? They are two separate things. You can have an AI which has nothing to do with human cognition, or you can have an AI which is more moderated or built up on human cognition. So what are we really benchmarking, that we should be clear about? And given data, why and when do people accept versus do not accept algorithms should be key, given that the whole world has been starting to implement national AI strategies. So what do we know? We already know a bunch of factors that influence behavior towards algorithms. It could be about how transparent the algorithm is, how much explanation the algorithm provides of why it is doing something or not, how much error the algorithm does. Interestingly, we have extremely low acceptability for errors by algorithms compared to humans. So the same amount of objective error, if done by an algorithm, we prefer never to use it again. But if it's done by a human, we completely forget it. If it's done by ourselves, then obviously we don't even care about it. So the error plays, or the known error is already playing a very important role. We have perception about algorithmic decision making. Many of the times it's subjective and wrong. Still now people think algorithms follow a series of steps, they are sequential and whatnot, like expert systems were, but they are, algorithms of 1980s. No modern AI algorithm, or very few modern AI algorithm, are rule based in the form of what they were as expert systems in 80s and stuff. There's domain and task specificity, which means that we accept AI in certain amounts of domains or certain kinds of domains and certain tasks within that domain and not in others. And now it's important for us to know which is what, which are the domains and tasks that we want AI and where we don't want AI. Then we have something about perceived understanding. If we think we understand, remember, think we understand, that may or may not have anything to do with actual understanding. But if we have perceived understanding of how an AI works, then our acceptability of the AI goes up. And for lower risks, we are more accepting towards AI, for example, in weather forecasting. Another thing that Longoni suggests, especially in healthcare or medical AI, is that we feel humans are sensitive to our uniqueness. So we go to doctors because doctors know us uniquely, but algorithms don't. So there is a perceived uniqueness about human actors, which is not there in AI. And these all factors lead towards our rejection of AI in multiple domains. What's the current status in our country? So this is some work that we have been doing. It's still under progress, but I'll give you a snapshot of where things lie as of now. You see that these are the areas that has been discussed by the National AI Strategy by Niti Aayog for India, which is finance, education, agriculture, smart cities, health, mobility. We also added governance and entertainment and lifestyle. And here you see the graphs. This is proportion of people. On the y-axis, you have proportion of people who prefer, either AI software versus human expert. And you see predominantly in our country, be it mobility, especially in healthcare, entertainment and lifestyle, education, and even to some extent agriculture, there's a strong preference for human experts over AI. Whereas for smart cities and for finance and for governance, we actually prefer AI software more compared to humans, at least the survey participants whom we had surveyed. And this is still not a very large study, but this is under progress. So, as data comes in, we'll see. But we see a clear divide already between domains where AI people think is acceptable and areas in which AI people think AI is not acceptable. This is extremely important data for Niti Aayog to figure out what are the strategies as we move forward. Why that's the case? So we also started understanding what could be the underlying cognitive mechanisms that explain this acceptability of AI. And here we see that two major things that we tested, which is perceived understanding, which is my sense of understanding how an AI might be doing this task. And the second is nature of the task, which is whether the task is objective or subjective. These become very strong predictors for algorithmic preference, meaning that there is clear domain and task specificity. Tasks which are more seemingly objective seem to be more okay with AI doing it compared to tasks which seem to be more subjective. Similarly, if I think I understand how an AI is doing a task, I am more okay with AI doing it compared to if I think I do not understand how the AI is doing this task. This is, predominantly true across domains. But as you see in agriculture, as I showed you previously, the preference for AI is higher compared to education or healthcare. What happens for governance? These are the typical areas in which AI is used in governance across the world, and most likely it is uh, coming to be used in India very soon, which is predicting of dropouts and detecting task evaders in the finance area, grievance addressal, predictive policing, parole prediction for prisoners, and determining fine for traffic defaulters. So there again, you see for things which are more numerical or more objective, like detecting task evaders in the area of income tax and fine for in the area of mobility, there our acceptance for AI using AI being used is much more already. But again, as you see, the perceived understanding of how an AI might be doing the task and the nature of the task both become predictors for our algorithmic preference, which we think are two major underlying cognitive mechanisms. There could be more. There is in fact one more that we are supposed to test out soon. But you know, this is what is right now very important for the national AI strategy. What action points can we take, and what are the practical advices that we can give to policymakers and designers from a behavioral perspective? Increase transparency. The more seemingly transparent the algorithms are, the more the acceptability. Increase explanation, this area of explainable AI, which essentially tries to explain how it reached a certain solution, and that is now slowly becoming to be made a mandate by many regulators. Perceived understanding and actual understanding. If you are understanding how an AI might be working, or if you are able to make people understand how an AI works, that can increase acceptability to a large extent. Give control to humans, give a little bit of control. So Date Ward's study is a fantastic one where they showed that a very small amount of control versus a very large amount of control did not matter. Any amount of control, if I have on an algorithm, I am more okay to using it compared to a case where I do not have control about the algorithm's functioning, even if I am a novice. And who knows what I'm going to do with my control, but still the sense of control makes people more acceptable towards AI. And make algorithms more human-like through framing. Make algorithms slow because humans are slow. Make algorithms uncertain because humans are uncertain. And frame algorithms to counter many of these aversions by, saying that this is unique towards you, or I've been working, and many kinds of framing manipulations that one can do in the design process. Now, let me move quickly to the second thread that I think is interesting or important. The second thread is behavior of algorithms themselves. So if you think about how algorithms behave, the first important thing is competency. Because competency, see, the whole point of trying to say use AI makes no sense unless you have shown me that AI actually works. So we have to have benchmark comparison with human versus algorithmic competence for the same amount of data, not the way of process. So a machine and a human might think differently. That's fine. But if a human and machine acts differently, or if the quality of the decision making is different for the same amount of data, then it's a matter of concern. And systematic studies for years, Dawes studied it in 80s, then Meal was there, Kahneman, Gigeranson, they all showed very simple algorithms, including linear models, which are overtly simplistic, do better work than humans, human experts, by the way. However, the problem with humans is this, according to me, and our discussion with my student Deepthi, is that we have an overestimation about how humans understand. Nowhere you will see some people asking, how did you judge my essay? I mean, how many students actually come up to instructors and ask an explanation of why the essay got that much mark, and you assume that this explanation is perfectly without any error? The explanation that is given by humans, or how many people go to a judge and ask, why did you exactly give this kind of a sentence? We somehow have an inherent bias to thinking that we understand how humans operate. And we somehow, that leads us to overestimating the competency of humans. That same bias makes us question algorithmic competency. But the result is that objectively, if you compare human experts versus algorithms, even simple algorithms, have consistently shown to be of better performers. This is a question about competency. There's two things about it. One is the outcome, which is what I was talking about. The other is the process. Now, do you want a machine or do you want an AI algorithm to mimic human cognition? Possibly yes, possibly no. So you can have an AI algorithm which is like a human brain, or you can have an AI algorithm which is not like a human brain. But in the practical world, what matters is that whether they produce the outcome which is of matched competency. So if you say that this is a sentence that a judge should give, or this is a sentence that an AI software should give, or this is a marks that a human essay evaluator should give, versus this is a mark that a AI system should give, for the same data, they should be of equal quality. But that quality has to be pre-designed or destined. It can't be the case that you always think the human is of a better quality, which is the bias that's inherent in our society. And that's a psychological bias. The second is data source. Data source is something that we have to be extremely cautious about. Like you saw in Microsoft's case, whether it is the Chinese internet structure versus a more free internet structure, the data source completely changes what competency an algorithm is able to achieve. And so does humans. So the same data source, if you are training a human to read x-rays to detect whether this person has got COVID or not, the same data source must be trained on the model and then compared for competency, which is not what is done a lot of times. Models are actually fed much more amount of data than is fed to a human, which is also actually wrong or biased against human experts because of the process issue. The machine learning models, as we have now, very few of them mimic human cognition. And the third issue is source code. Source code, even if we have access to source code, that doesn't mean it is going to serve any good purpose. Most of the source code is illegible for most people, including regulators. You really need to be a computer science expert to be able to understand source code. So just access to source code is not enough. What we need is regulatory consequences of source code manipulation, both legal and regulatory consequences, not the access. Now, the second issue about behavior of algorithms that we should be extremely cautious about is bias or algorithmic bias. Now, bias can be multiple ways, and it can come from multiple things. One could be the bias based on the design of the algorithm. The other could be the bias based on the data that is fed to the algorithm, especially for machine learning algorithms. Similarly, bias can be intentional and unintentional. In all the four situations, it is a bias nevertheless. So an unintentional data-related bias, which is what happened for Microsoft, is something that we should care about. Obviously, the worst part is intentional design-related bias, which is when intentionally the designer of the algorithm is making the algorithm up to be biased in a specific way, which we have also seen in the news and information industry a lot. The intentional data-related bias is extremely rampant, including in data sets that you would have some, faith in. The unintentional design-related bias is very risky. In fact, the unintentional row, both for design-related and data-related bias, is predominantly what should be a matter of concern for behavioral AI. Because you don't have intentions for doing something, but you see it in action. And that can only happen through typical probing, which I will come to later. Interestingly, you find that unfair outcomes caused by algorithms. So for example, showing a certain kind of job posting to males versus a certain kind of job posting to females. Discrimination, where we have these cases where algorithms have thought that a black person is more at a potential chance of committing a crime compared to a white person wrongly. are potentially unintentional, but they are nevertheless both design and data related biases. And that has happened from both big and small organizations. So there are cases from Google's cloud, there's cases from Microsoft, there's cases from Tesla, and there's, of course, smaller organizations where we have seen a huge amount of these biases in the algorithms, which works against people. So how do we do about what do we do about it? I suggest we have targeted probes, and this is going back to the machine behavior agenda that Revon and colleagues have suggested. We study here in the second thread, the behavior of algorithms. We study four things. One is individual algorithms, where we do behavioral studies about human algorithmic interactions. We study how groups of algorithms behave together, like in algorithmic trading. We have multiple algorithms interacting with multiple algorithms, and we see what's the effect of that on the system. We have algorithm and groups of people. So we have one algorithm which is behaving in different kinds of people, and see how the same algorithm, when put in one group of people, behaves differently versus another group of people behaves differently. Again, a behavioral question. And fourth is a systematic question, which is when you have groups of algorithms interacting with groups of people, what's the dynamics that comes out from such a systemic interaction? So these four specific probes will help us, I think, move towards the behavior of algorithms. Uh, the last thing about behavior of algorithms is that behavior is not independent of perception. So when you talk about behavior, we also have perceived behavior of algorithms, which goes back to the cognitive science area now, which says that how are we thinking about algorithms and machines? And here, there's a very recently one study only I have seen, but there are plenty of previous literature in neuroscience or neuropsychology that one can borrow from, where people have looked at brain responses when people act with humans versus algorithms versus machines. We have to also study the affective response to outcomes by algorithms. When the same algorithm or different algorithms cause certain outcomes to us. For example, when I end up losing money because of an automatic AI algorithm that has been part of my national pension scheme, that has been kind of imposed on us by government policies, compared to when I get a gain from the same, what does that happen, and how does that differ depending on the agent which has caused it, being a human expert versus a AI algorithm. And we should also keep in mind all the different heuristics and biases that we already know, which means availability. Once the Tesla crash happens and once the Uber crash happens, the acceptability of automated vehicles drastically falls down. It's wrong because we are having a base rate neglect. In fact, if you use algorithms, the chance of accidents go down objectively if you do consider the base rate of accidents on the road. There's also something called subjective risk that was talked about by Paul Slovic in JDM, in judgment decision making research extensively. The risk that we talk about almost always is not objective risk but subjective risk. So all of these issues of how people behave towards how people perceive the behavioral algorithms has to do with subjective risk estimations and not objective risk estimations. So the subjective risk of algorithms actually is something that we have no idea about. In fact, there's one paper I've seen by Gigorancer and his group, which studied the objective amount of errors that we are accepting from algorithms. The subjective amount of errors we don't know. The objective risk that we are able to accept from algorithms also we don't know. The subjective risk that we are able to accept from algorithms also we don't know. So all of this needs much more research is the basic point. So my summary is this. We create a behavioral AI agenda, which has two threads. One is a behavioral response to AI algorithms. The second is behavior of algorithms. And relatedly, as I said, perceived behavior of algorithms also. And the third, which I am an expert, but there are important issues and people should study it from policy or from philosophy or from management, which is about policy regulations based on what are the outcomes of behavioral AI. It needs interdisciplinary direction, so you can't study it alone. So we need people from computer science or robotics and people from social science and perhaps even humanities to come together. And we need multiple methods. The multiple methods, we already know what methods we have to use. We have somewhat of a clear idea, which means experimental, survey, computational models, neurophysiological approach, but that's not a problem. But these two threads have to come together. So we have, I say that we have 4 action points. One is we have to together join this behavioral AI initiative from different areas. Different areas, I mean different subject areas, obviously from different institutions, but at least from different subject areas, and generate these kinds of data first, experimental, survey, and computational, on which we can sit and deliberate and write white papers on it. We also should do more of deliberative polling. So deliberative polling is when you first poll a group of people and figure out what is their preference towards a certain technology or anything. And then you deliberate over it, which means that you increase objective understanding of the AI in this sense, and make them deliberate over this issue for a couple of days, and then do a repolling to see whether that has changed people's opinions towards it. And together, these findings will assimilate or needs to assimilate already existing knowledge that we have from cognitive science, typically from judgment and decision-making research, that creates usable behavioral insights for AI research. Because eventually, we want the behavioral insights to feed into AI research to change the way AI is seen and AI works out. Because remember, AI is touching all the important domains of our life. So it's not a question of computer scientists or not a question of AI researchers, but a question of common normal citizens. And that's why we should be worried about it. Towards the end, this is from the OECD website. You see that this says where AI strategy is complete and where AI strategy is forthcoming. A lot of the nations across the world has already completed AI strategies, including the mostly the developed ones. There are areas where it's forthcoming, like Australia and Norway, Nordic areas. India, right now, the AI strategy is embedded in the broader strategy of national development. So there's a very, very good time for us to make these interventions, create this data, and have serious dialogues with important stakeholders. So I'll stop here. This is, my a call, an invitation, and a need towards moving towards behavioral AI. And if you have questions, of course, I'm happy to take them.